Hello all, welcome to the first session on introduction of function. Now function is a word which is very common in the math world and we talk about this term almost every time. No matter whether we are in the middle school, high school or college, we all got to deal with functions. Okay, so let's spend some time here understanding what is a function or what is something which makes a function or which does not make a function, correct? So before we get to that, we got to understand a little bit about the variables. Now, a function essentially is nothing but a relationship between two or more variables. It could be 3 variables, 4 variables, 5 variables, whatever. When we go beyond 2 variables, we come into things like calculus and multivariable and things like that. So for the purpose of this session, we will confine ourselves to 2 variables, correct? Now, what are those 2 variables which are involved in this relationship, right? The first one is the independent variable, typically denoted by x, right? So as the name suggests, this is the independent variable and it can take any which real value, right? Whatever value it wants, it can take that value as long as it's within the real horizon, right? The other variable is y, which is the dependent variable, typically denoted by y or fx, right? This is the dependent variable. Now again, as the name suggests, this variable depends upon the value of x to determine its value. It cannot take any value it wants to, right? It has to depend upon x, right? So these are the 2 variables which are involved into that relationship. So what does it mean? Does it mean that any relationship between y and x will qualify for a function? No, that's not the case. The trick here is to understand that the relationship should be in such a way that for one value of x or for any value, any particular value of x, there should be only a unique valid value of y, right? The point I'm trying to make is that if you have a relationship between y and x, but for any value of x there are 2 or more values of y, then that is not a function, right? That is a relationship, but that is not a function. Let's now try to visualize that in terms of graph, right? In terms of picture, what does it mean? Let's take some examples of some relationships to understand that which are the relationships which qualify for a function and which do not qualify for a function and why so. Now let's try to understand that which of these relationships qualify for being a function and which don't, right? So let's see. So here, right? Here are the values of x and here are the values of y, correct? For any particular value of x, you have a unique value of y, correct? For this value of x, you have y, for this value of x, you have y, and so on and so forth, right? So for every unique value of x, there is only one unique value of y, and hence this relationship qualifies to be a function, right? Let's look at this relationship now. Again, similar to this one, right? When x is this, y is this, when x is this, y is this, and so on, right? So for every unique value of x, you have a corresponding unique value of y, correct? So this also qualifies to be a function. Let's look at this one. Let's say this is the value of x. For this value of x, you have one value of y and you have the other value of y, correct? Let's say this is -1 and this is, let's say, 4 and this is -2. So for x -1, when x is -1, you have 2 values of y, 4 and -2. Here at this point of time, for something like this, for a relationship like this, it is not a function. Coming back to our original definition, right? For a single value of x, you cannot have 2 different values of y. It has to be a unique value of y. Hence, this is not a function, right? This is also something which is called as, this logic is called as a vertical line test. Basically, when you draw a vertical line across the function, across the relationship, it should not cut the graph in two times. If it's cutting the graph at 2 different points, it is not a function. Coming back to this circle, which we all know, right? Again, the similar thing, right? For this value of x, let's say you have 2 values of y. For this value of x, again, you have two values of y. For this value of x, you have two values of y. So there are so many points of x for which the single x is giving you two values of y, and hence this is also not a function. Again, we call it as a vertical line test in our math world. Coming to this one, right? This value of x, we have a value of y. This value of x, we have a value of y, right? For every x, we have a unique value of y, and hence this will also be qualified for a function. Same thing here. No matter what the shape of the relationship is, doesn't matter. All we are going to see is that is there any value of x for which there are two values of y? If there are, then it is not a function. If for every value of x there is only a single value of y, it is a function. So this is a function. So just wanted to have this quick brief introduction session trying to show graphically, pictorially, that what relationship qualifies for a function and what not. Of course, there are several aspects which come into picture in terms of what are the different types of functions, right? How do we plot a function? How do we solve a function, and so on and so forth. And that's something which we'll cover in our next session. Hopefully you guys did get some good idea in terms of what is a function, what are the variables involved, what is a relationship. Not every relationship is a function, and so on and so forth. And we will meet in our next session. If you like the video, please do like and subscribe. Thank you.